Hello, Assalamualaikum warahmatullahi wabarakatuh. So today we are going to present computer organization and architecture group project. So we choose project number 1, which is simple calculator. The purpose for this project is to create a simple calculator in MIPS. Then it will perform basic arithmetic, which is addition, subtraction, multiplication, and division. The key features for this project is where user will input two integers and an operator. It will display results or error message for invalid operators or division by 0. The programming environment we are using is Qt Spim Simulator. For the implementation details, let's start with the program structures. The program is divided into two key sections. The .data section stores static data like prompts and error message. For example, we use a string to prompt the user to enter the first integer. The .type section contains the executable instruction. It's modularly organized into parts for input handling, arithmetic operations, error handling, and result display. These structures ensure the program is easy to understand and debug. For the key logic, the main logic revolves around 3 steps. First one is input handling. The program prompts the user for two integer and an operator using MIPS syscalls. Second, operation selection. Based on the user's operator input, the program branch into the corresponding arithmetic operation. For instance, if the operator is add, the program uses the add instruction to calculate the sum. The third one is error handling. The program checks for invalid operators and handles division by 0 gracefully, displaying error message when needed. Finally, the result is displayed to the user using the appropriate syscalls. For the register usage, to manage data, we use specific register. The T0 stores the first integer, the T1 stores second integer, the T2 stores operator, which is add, minus, multiplication, and division. The T3 used for stores result of the calculation, and A0 is used for syscall arguments, for example, strings or integers. The V0 is used to specify syscall type and stores return values. As you can see on the screen, you can see the example for the output. In this case, we use addition case. So the user will input the first integer, which is 5. It will store into the T0. And the second integer, user will input 3. It will store into T1. And then system will ask the user to choose the operator, which is add. And the operator will store into T2. It will add 5 and 3. And it will show the answer, which is 8.
So, hi, my name is Adib. So, for the question 2 is logic and looping structures. So, for loop and control structure, simple calculator uses the following logic and looping structures to perform its operations. So, we have three types of loop and control structure. So, for the first one is input loop. Input loop is a loop is used to ensure the user enters valid inputs. For example, it repeatedly prompt for two integers until valid numbers are provided. It is also use branching instruction to check conditions and look back for incorrect input. And for the next loop and control structure is menu loop. Menu loop is the program that presents a menu for operation selection such as addition, minus, multiplication, and division, and loops until the user makes a valid choice. For example, conditional checks redirect the follow back to the menu prompt if the operator is invalid. And for the last loop and control structure is error handling in division. Error handling in division is when division is selected, a conditional check ensures the second integer is not 0. If 0 is detected, the program outputs an error message and loops back to prompt the user for a valid second integer. So for B, conditional checks and branching. The program uses conditional checks to control its flows. So for the first one is operation selection. Based on the user's choices, the program uses branching to execute the corresponding arithmetic operation. And for the second one is error handling. For division, zero divisor triggers a branch to an error handling routine, ensuring program doesn't crash. And for the third one is loop continuation. After an operation completes, the program may prompt the user to perform another calculation or exit controlled by a conditional loop.
Control flow and error handling. Control flow management. Control flow in the program is managed using conditional checks and label section of code. Here how it transitions between different sections. 1. Input handling. The program prompts the user for input, two integer and an operator sequentially. After each prompt, control transition to a section that reads and stores the input. 2. Operation selection. The program compares the operator input plus minus star slash with predefined values using CMP instructions. Based on the operator, it jumps to the corresponding arithmetic operation section. Add number, subtract number, multiply number, or divide numbers. 3. Error handling in division. Before performing division, the program checks if the divisor is 0 using CMP and jumps to division error if true. If the operator is invalid, it jumps to invalid operator. 4. Result display. After completing the arithmetic operation, the program transitions to the display result section to print the result. After displaying the result, control flows to the exit program sections to terminate gracefully. 5. Program termination. Regardless of the path taken, the program always ends in exit program, ensuring a clean exit. Error handling mechanisms. The program implements the following error handling mechanisms. 1. Division by 0. Before performing division, the divisor is checked to ensure it's not 0. If the divisor is 0, the program jumps into division error, where an error message is displayed and the program exits. Division by 0 is undefined behavior in arithmetic and causes a runtime exception in x86 assembly. Handling this gracefully prevents crashes and improves program reliability. 2. Invalid operator. After reading the operator, the program checks it against valid values. If the operator doesn't match any valid value, the program jumps into invalid operator, which could display an error message, though currently optional. Preventing invalid operation ensures the program behaves predictably and avoids performing unintended instruction. 3. Input validation. Although not explicitly implemented, checks can be added to ensure valid numeric input. For example, rejecting non-numeric characters or values outside the range.
5. User interface design. So for the first one is interaction with the user. The program will prompt the user to input two integers and an operator. For example, like addition, minus, multiplication, and division. After processing the input, the result will be displayed with clear formatting. If division by 0 is attempted, an error message such as error division by 0 is not allowed will be displayed. B. Enhancements to user experience. Error messages are displayed when invalid input is provided. Additional prompts guide the user to re-enter data in case of errors, ensuring smooth interaction. Lastly, outputs are formatted neatly, readily, using alignment and speaking to separate inputs from the results. 6 challenges and solutions. For the first one is challenges encountered. Managing user input validation. Ensuring only valid integers and operators are processed by the program. Next, debugging division by 0 handling. Ensuring the program does not crash when division by 0 is attempted. And next is maintaining clarity in assembly code structure while implementing control flow and loops. And B, solutions. For the input validations, implemented conditional checks to filter invalid inputs before proceeding with calculations. For example, checking if the operator matches one of the allowed values. Next is error handling for division by 0. Added additional check before executing the division operating with a specific branch to display an error message. Next is program structures. Organize the code into sections and use comments to outline each step, making the logic more understandable during debugging and execution.
Okay, for the conclusion and reflection. For the key learnings, our team gains skills in register usage and conditional branching. And we learned to handle syscalls for user interaction. For the takeaways, we reinforce assembly language concepts like arithmetic operation and error handling. And the last one, we build confidence in managing low-level programming challenges. That's all from us. Thank you.